All right, scholars were reminded that the definition of absolute value is the distance between a number and zero on a number line. Today we're also going to be using a new vocab term, addend. An addend is something that's being added. For example, if I'm saying 5 plus 4 equals 9, this is my first addend, 5. And this is my second addend, 4, and 9 is my sum. Write that down. For your do now, you were asked to do as much as you could of the classwork for today, starting by representing the sum of 3 plus 5 using arrows on a number line. We always start at 0. We represent 3 by going 3 units to the right. 1, 2, 3. We represent 5 by going 5 units to the right because it's positive. 1, 2, 3, 4, 5. Then we circle where we land, and that's our sum. The arrow that represents 3 is 3 units long, and it goes to the right because it's positive. The arrow that represents 5 is 5 units long, and it goes to the right because it's also positive. What was the sum that we found? If we look, our sum was 8. And the last part on the front says, if you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? Let's go back and look. If I were to represent the sum using an arrow, the sum is 8. I could represent the sum using an arrow that goes like this. It is 8 units to the right. Get done with that and flip the page. This question asks, what is the relationship between the arrow representing the number on the number line and the absolute value of the number? Let's go back and look. When we represent a number with an arrow, how is the absolute value related? When we represent 3, it's 3 units long to the right. 5 is 5 units long to the right. 8 is 8 units long to the right. So the length is the absolute value. We've talked about this before. The length of the arrow is the absolute value of the number. For example, when we made our 8 arrow, the absolute value tells us that it's going to be 8 units long. Do you think that adding two positive numbers will always give you a greater positive number? Why? Let's look again back at our picture. We added a positive number and another positive number, so we got an even bigger positive number as our sum. If I add two positive numbers, will I always get a greater positive number? The answer is yes, because we're going to the right with the first positive number, and then we go to the right some more. So we end up with an even bigger positive number. All right, I want you to try part B on your own. You're representing the sum of -3 plus -5 using arrows that represent -3 and -5. So just like we've been doing, except now you're adding -3 and -5, and I want you to answer the questions to the best of your ability. Okay, this is what you should have on your page. -3 plus -5 makes -8. The arrow that represents -3 is 3 units to the left. The arrow that represents -5 is 5 units to the left. So my sum is -8. Give yourself a check for everyone you got right and flip the page. If you were to represent the sum using an arrow, the sum was -8. The arrow would go like this, 8 units to the left. Do you think that adding two numbers will always give you a smaller negative number, and why? That's similar to what we did with addition, because yes, to the left, and then more to the left equals more negative number, also known as a smaller number. Write that down. What do both of these examples have in common? Well, a lot of things, right? We're adding numbers of the same sign, so we get a bigger number of the same sign. The length of the arrow is the sum of the absolute values. That's kind of the main point they want you to get, is that the length of the sum arrow, in this one it was 8 units, but for both of them it was 8 units, is equal to the sum of the absolute values. Absolute values. So both times we were doing a 3 and a 5, but in the first one they were positive, and in the second one they were negative. -3, absolute value is 3. -5, absolute value is 5 in the second one. And then, so that means that our sum arrow is 8 units long because 3 plus 5 is 8. Get finished with that and scroll down. Exercise 2 says decide whether the sum will be positive or negative without actually calculating the sum. I'm going to do 2 examples of this, and then I want you to do the last 4. This is a negative and a negative. When we add together 2 negatives, we get another bigger negative. So I'm going to write negative. This is a positive and a positive, so I'm going to get an even bigger positive just like we did. This is a positive. Take some time and fill in the rest of these on your own. All right, check to see how you did and get ready to flip the page. Now we're going to actually find the sum of these. I'm going to do it really quickly and show you. These are positives, so all I do is add them together. These are negatives, so what I do is I know it's going to be negative. This one was positive. But I'm going to add them together, and then I put the negative on front. This one's going to be negative because they're both negative. I add them together, and I put the negative on front. This one's going to be negative because they're both negative. I add them together, and I put the negative on the front. Get that written down and scroll down. Example 2 asks you to represent 5 plus negative 3 using arrows on the number line. I want you to go ahead and do this, and then we'll come back. All right, check to see that you got everything correct. 5 to the right, 3 to the left. We land at 2. That's our sum. Get that written down and flip the page. Which arrow is longer? Let's look. Which arrow is longer? The 5 arrow, that's right. What is the sum? 2. And if we were to represent it with an arrow, it would be 2 units to the right. Now I want you to do this one, represent 4 and negative 7 on the number line with arrows. It should look like this. In the 2 examples above, what is the relationship between the length of the arrow representing the sum and the lengths of the arrows representing the 2 addends? Remember, addends are things that are being added. So in the 2 examples, in this one and in this one, what is the relationship between these lengths and this length? This is 5 and 3. How do we get 2 from 5 and 3? This is 7 and 4. That's how long they are. How do we get 3, or negative 3, from 7 and 4? Remember the length. This is 3. The sum arrow distance is the difference between the addend arrow lengths. For example, on this one, we had 7 units long, 4 units long, and this one is 3 units long. 7 minus 4 is 3. What is the relationship between the direction of the arrow representing the sum? What's the direction of the arrow representing the sum? And the direction of the arrows representing the 2 addends? These are going right and left, but this one's going left. So how do we know which way the sum is going to go? I know that the sum arrow goes the direction of the addend with the larger absolute value. Write a rule that will give the length and direction of the arrow representing the sum of 2 values that have opposite signs. I want you to write a rule in your own words. Okay, I'm going to show you some examples of how to do this. Circle the integer with the greater absolute value. That's this one and this one. I'm just going to do these 2. Decide whether the sum will be positive or negative without actually calculating the sum. The larger one is 2, so I know this one's going to be positive. You can just write pos. On this one, the larger one is 9, so I know whatever the sum is going to be negative. You can just write neg. I want you to do the rest by yourself. Then when I'm finding the sum, I can take the difference of the 2 and put the right sign in front of it. This one's going to be negative. This one's going to be positive. This one's going to be negative. I write 8 minus, let's do 16 minus 8. That's easier. And then I write the correct sign in front of it. Do the other 2 by yourself.